Welcome back to the Model Leader. I'm Eric, a retired physicist and systems engineer. This channel is where we try to bridge the gap between physics, technology, and simulation. And today we're diving into that hot topic of the past few weeks, loops. So we're all familiar with vibe coding. It's a sequential chain where the human steers the AI in some kind of programming task. So you give the AI a command like, make this button open a new window. Then the AI goes off and does some work. Comes back, you inspect the result, and then begins the back and forth. Fix this error. Why are these tests failing? Please undo that thing that you just did that I didn't ask you to do. And so on. It works, but it's still the human supplying the control flow. The model does chunks of work, but the human is deciding what to try next, what counts as success, when to keep going, and when to stop. That's why the experience can feel both powerful and primitive at the same time, because it's not really a mature programming style. It's closer to back when people programmed in assembly language. It's really powerful, but you have to give it every instruction manually. So now there's something more interesting happening. Now we're talking about loops. So you've got AI agentic workflows where the model is observing the state, making changes, checking the result, and then deciding to either continue or to stop. So it's simple, but yet it's not. And loops may be the first real programming primitive of AI agents. But the problem is loops are still written as prose. If we want to teach agents how to run loops reliably, we're going to need a notation. And that's what I'm proposing here, Agentic Loop Notation. So the loop changes how we're interacting with AI. The human's no longer laboriously instructing the AI on every step. Instead, the human defines the loop. We set the goal. We define what it is the agent should be looking at. We define what it should change, what checks must it run, and how it should be deciding to continue or to roll back or to escalate to the human. So that turns the AI into part of the control flow. Need a verifier, because without a verifier, a loop is just repetition and the AI will just wander away from what the real goal is. But with verification, then the loop begins to resemble a traditional programming control flow. So the good news is that we have examples that are showing up. The forward future loop library, sorry about that, link down below, collects practical AI agent loops for a variety of use cases. And that matters because examples are how we learn. But the examples are written as natural language prompts, not a criticism. But the problem is the prose can hide the structure. Right? A good loop prompt is going to contain a goal, point to some context, put some guardrails up, tell it what to check, and how to end the loop. Those pieces in a natural language prompt can be all mixed together, and some might even be missing. Humans can read it. Certainly the person making the prompt knows their intent. A good frontier model can generally follow it, but the structure is not explicit. So that makes loops harder to teach, harder to compare, to audit, to reuse, and ultimately to insert into skills. That's why I believe loops need a notation. So here's my proposal for an agentic loop notation. This is just a first pass. The goal is to make the control structure visible. Good loop has a goal, it has a context, it has the guardrails, it has a well-defined cycle, and it has a verifier at the end of the cycle so it can decide whether or not to go back to the top and do another cycle or to end. And then in addition, it has the stop conditions, and finally, it needs to return proof of its work. So the cycle tells the agent how to move, how to observe, act, verify, and decide. The stop block tells the agent how to finish. Success, a no-op, a stall, maybe you hit a iteration limit, or you've been blocked for some reason. Those ending conditions can be pretty important, since if it runs away, you can run up quite a bill. So a no-op isn't necessarily a failure. Sometimes there's nothing actionable to fix, and the loop needs to tell you that. Blocked isn't a failure either. It just means that the agent has run up against a lack of authority or access or needs more information. The stall is pretty important. That means the loop is running but not improving, and you want to detect that. So let's go to a concrete example. So I've got a prompt loaded here into Codex. It's just a simple inspect the code base and documentation and find anything stale. It's kind of the most basic loop you could try to run, just a documentation. So what you should see running here is a skill that I've developed in Codex to handle all this, and I'll put the link down in the description. So let's hit run here. So as you can see, it chose to use my skill. It understood the prompt, and it gave us the ALN, and then importantly, it ran Loop Doctor to determine that some of this may be a little too vague. Then it tells you where the items where you probably want to go back and correct. And it also gives you an example goal prompt. So as you can see, the notation forces a useful discipline. It says what the agent can touch. It says what it must not touch. It says what check is required, when to stop, what evidence to return. Now let's try a second example. This example comes from the loop library I mentioned, and it's Matthew Berman's example called the doc sweep. So it's going to translate the attached prompt into ALN. Okay, so let's run this. You can read this. I can paste it down below if people request it. So this is an interesting result. And this is the first time I've done this. The loop doctor found that there are certain elements in that prompt that are vague. There's no explicit authority boundary. The request to open a pull request isn't well bounded. You can see there's a number of things that really should be corrected before using this to generate a goal prompt or even a skill from it. So this is the real utility. The ALN is not meant to be decorative, it's meant to be operation. You should be able to take a loop written in prose like we had just translated into ALN, audit it, repair it, and then, when you're satisfied with it, export it in a form that you want, such as a goal prompt. So this is the shift that loops bring to it. The future of AI-assisted work is not going for better one-shot prompts. It's the agents performing a feedback-controlled operation. We move from linear prompting to agentic coding with control flow over the model-mediated work. So agentic metaprogramming begins to be a discipline when we can define and reuse and compose these control loop structures. Loops are just the first primitive, but they needed a language, and ALN is my attempt at creating that language. Thanks for joining me, and catch you again next time on The Model Ear.